Today we visit Isobionics in Geleen in the Netherlands. Dr. Georg Lenzen, Director R&D, will give us an overview on their expertise in the biotechnological production of terpene-based flavor molecules.
Today I would like to tell you a bit about our company, Isobionics, and how we use biotechnology to produce flavor and fragrance ingredients. We started 10 years ago to develop the fermentative production of isoprenoids, also called terpenes, as flavor and fragrance ingredients. Our first product, Valencine, an orange flavor, was actually the first fermentation-based terpene flavor brought to market. In the meantime, we produced several other products like note-ketone, a grapefruit flavor, and beta-bismolene, a lemon flavor, and we are continuously developing new products, especially citrus flavors, but also, for example, patchouli and sandalwood isoprenoid products. All our products and product developments are isoprenoids. So what are isoprenoids? They actually form the largest group of natural compounds with more than 50,000 known members by now, and they are all built from C5 isoprene units. They occur, for example, in plants, but also in many other organisms, but often in very low concentrations. They are often also difficult to produce by chemical synthesis due to their complex chemical structures. So what we do at Isobionics is to produce them by fermentation, which is a cost-effective and scalable method. Isoprenoid ingredients are important in many markets, like food, for example, vitamin A and vitamin E, or the sweetener stevia, as cosmetic ingredients, for example, coenzyme Q10, as pharmaceuticals like the antimalarial artemisinin and the anti-cancer drug Taxol, and also as polymer building blocks like isoprene in rubber. We develop and sell our isoprenoid products for the flavor and fragrance market, in which isoprenoids play a big role since all the main components of plant essential oils are isoprenoids. We develop and produce volatile isoprenoids with 2, 3, or 4 isoprene units, termed mono, terpenes, sesquiterpenes, and diterpenes, respectively, which occur natively in complex mixtures in essential oils. They are traditionally obtained by plant extraction, for example, in the case of cold-pressed orange oil from orange peels, or by steam distillation, for example, in the case of sandalwood oil from the sandalwood tree. Due to their complex structure, only few can be made by chemical synthesis. We produce our isoprenoids by fermentation. Sometimes the fermentation product is further converted into the desired ingredient, often by oxidation, for example, in the cases of note-ketone and xanthanol. The fermentative production process is straightforward and a bit like brewing beer. We start from sugar and add a microorganism containing a plant terpene synthase to it. The fermentation takes place in large vessels with more than 50 cubic meters size. At the end, the isoprenoid product is isolated and purified by distillation, similar to the isolation from an essential oil. This technology offers several advantages over the plant extraction or chemical synthesis. We have constant quality and availability. We are not depending on harvest. The process is scalable, very cost-effective, and very sustainable due to the use of renewable resources. Also, we do not have any pesticides in our products, and we can even create new products which were not accessible by traditional technology. So overall, this is a breakthrough technology which brings major advantages to the conventional production methods. The products out of the fermentation process are not harvest dependent. The weather has no influence on the quality or availability of the products. Biosynthesis used by nature is very efficient, and therefore we can make new products at very high purity. This technology uses glucose instead of scarce raw materials. A relatively cheap glucose is the main raw material and can be produced locally. This saves cost, and we prevent having pesticides in our products. Compared to the traditional way of production is quite inefficient. For the production of Valencine from orange oil, 160,000 oranges are needed to produce 1 kilogram of product. Supply is harvest dependent and does fluctuate a lot. The environmental footprint, water, pesticide use, is often very high. For citrus ingredients, there is the additional problem of citrus greening disease, a severe plant disease which is threatening supply of orange oils. As microorganism in fermentation, we use Rhodobacter, which is a natural isoprenoid producer. It is robust and scalable in fermentation with high tolerance to isoprenoid products. Importantly, it does not produce any problematic volatile side products by itself that would appear as off-odors in the product. Our producer strain contains a double isoprenate pathway, an intrinsic so-called non-mevalonate or MEP pathway, and an additional mevalonate pathway from another carotenoid-producing bacterium. This allows for a higher conversion of the substrate glucose into isoprenoates. In addition to this, our strains contain a plant-derived terpene synthase, which converts the universal terpene pyrophosphate precursor into the specific product or specific product mixture. By changing this terpene synthase, we can quickly generate a new terpene production strain. Once such a strain has been made, it is tested in our bioprocess development lab. There, the fermentation process is also optimized and scaled up before it is transferred to an external production site where commercial production is performed. For production, we have established partnerships with companies with large fermentation capacity. Our products are used in food, and we have established corresponding quality systems, for example, ISO 22000 certification. Also, all our flavor products are kosher and halal approved. Current products are Valencine, a natural aroma compound in oranges, which is used as a flavoring agent in beverages with a use level of around 1 parts per million. Also, it is used in the production of note-ketone. Note-ketone, another one of our products, is a grapefruit aroma, an important grapefruit aroma with a high value flavor with low natural abundance. The odor threshold for this product is extremely low, below 1 part per million, and this product is also used to some extent as fragrance ingredient. A third product is beta-bisabolene, found in lemon and bergamot, which has a very pleasant balsamic green odor, and we produce a 90% pure product, which, like all our products, is pesticide-free. Our product range is growing quickly, with several new products per year, many of them citrus ingredients. Furthermore, we are also developing other isoprenate products like sandalwood and patchouli.